everyone, and welcome to this grade 9 mathematics lesson where we will be exploring solving quadratic equations. My name is Miss Donnell Phillips. Let's get started. Solving quadratic equations. Now, in our previous lesson, we would have explored how we factorize quadratic expression. In this lesson, we're going to be focusing on solving quadratic equations. So, what exactly is a quadratic equation? A quadratic equation is a second-order polynomial that have the form f of x is equal to ax squared plus bx plus c, where a is a non-zero constant, b and c are constants of any value, and x is the independent variable. The name quadratic comes from quad, meaning square, because the variable gets squared. So all this is saying is that a quadratic equation is written in the form ax squared plus bx plus c, and the a value could never be equal to 0. The x value is the value that we're actually solving for, and the b and the c value are pretty much just constants of any value. So we did explore how we factor quadratic expressions using the AC method. Now, in order for us to solve quadratic expressions, we pretty much follow the same steps that we use to factorize quadratic expressions using the AC method, but we go one step further. So to refresh ourselves, the first step would be to find the product of A and C. The second step, list all the products that equal to A times C. The third step, check to see if numbers listed equal to B when added. The fourth step, rewrite expressions with the new numbers taking the B terms place. And the final step, group and factorize. So now that we're going to be solving quadratic equations, we're going to be following these 5 steps, but we have to go one step further in order for us to solve the quadratic equation. So what happens after we factorize the expression? Number 1, we set each factor equal to 0. Number 2, we solve each of these equations. And number 3, we check by inserting your answer into the original equation. So let us say we had to factorize x squared minus x minus 6 is equal to 0. And after we've used the AC method, we found that to be x minus 3 and x plus 2. The next step we have to do is to set each factor equal to 0. So the first bracket, we have to put it equal to 0, and the second bracket, we also have to equal it to 0. So we would have, in this case, x minus 3 equal to 0 and x plus 2 equal to 0. We have to then solve for x. So if we have x minus 3 is equal to 0, and we want to get rid of the negative 3 to leave the x on that side alone, what we need to do is add 3 on both sides of the equation. So x minus 3 plus 3 would just leave x only, and 0 plus 3 would give us 3. So here we have solved for x minus 3 is equal to 0, and we have found that x is equal to 3. On the other hand, the second bracket, x plus 2 equals 0. If we want to get rid of the positive 2, we have to subtract 2. And because it's an equation, what we do on one side of the equal sign, we have to do on the other side. So x plus 2 subtract 2, we're left with just x. And 0 subtract 2, we're left with negative 2. So after we have solved this quadratic equation, the values for x are 3 and negative 2. In case you're a little confused on this step because, it's a picture, we are going to be going through about 3 examples so that you would be able to follow the steps. So the examples that we're going to be looking at are 2x squared minus 5x minus 3 equals 0. X squared minus 10x plus 21 equals 0, and x squared plus 6x plus 9 equals 0. The first example that we have to solve is 2x squared minus 5x minus 3 equal 0. And as usual, the first we need to factorize, and then we would be able to solve for the 2x values. So we have our a term, our b term, and our c term. As usual, we find our AC values. So AC would be a times c, which is 2 times negative 3, and that would give us negative 6. So the two values that we could multiply, that would give us negative 6, and add, that would give us negative 5, are negative 6 and 1. Because negative 6 times 1 is negative 6, and negative 6 plus 1 is 5. So we're going to replace the b term with negative 6x and x. So 2x squared minus 6x plus x minus 3 equal 0. Group them, first pair, second pair. So the first pair, we have 2x squared minus 6x. We could take out the 2x squared into divided by 2x would just give us x, and negative 6x divided by 2x would give us negative 3. So we have 2x into x minus 3. Next bracket, what is common? We could use positive 1. X divided by 1 is x. Negative 3 divided by 1 is negative 3 equals 0. Good. So we're going to write back what's in the bracket. We have x minus 3 in the first bracket, and then we have 2x plus 1 in the second bracket. All of this equals 0. At this point in time, what we're going to do, we're going to separate them, and we're going to equate both brackets to 0. So we have x minus 3 equal to 0, and then we have 2x plus 1 equal to 0. So we could just solve. We have x minus 3 is equal to 0. Because we want to find the value of the x, we're going to take the negative 3 across the equal sign. So x is equal to, when we transpose a negative 3, it becomes a positive 3. So we now have x is equal to 3. So the first x value that we have is x is equal to 3. Next, we're going to solve the second equation. 2x plus 1 equal 0. 2x, when we take this positive 1 across the equal sign, it becomes negative 1. So 2x is equal to negative 1. Because the 2 and the x are multiplying, when we take the 2 across, it will now divide. So x is equal to negative 1 divided by 2. So x is equal to negative half, and x is equal to positive 3. So these are the two x values. When we solve this quadratic equation, 2x squared minus 5x minus 3 equals 0. Next example, x squared minus 10x plus 21. When we rewrite this, matter of fact, we're going to find the AC value. AC is equal to 21, and the 2, since AC is equal to 21, we now have to find two numbers. When we multiply, it would give us 21, but when we add it, it would give us negative 10. And those two numbers that we're going to work with would be negative 3 and negative 7. Because negative 3 times negative 7 is 21, and negative 3 plus negative 7 gives us 10. Negative 10. So we have x squared minus 3x minus 7x plus 21 equal 0. You have to put in equal 0 because we're solving it now. We're not just factorizing it, but we're solving it. So we have first pair, second pair. Only thing common here would be the x. So x into x squared is x, and x into 3x minus 3. Second pair, we have negative 7x plus 21. We could take out the negative 7. Negative 7x divided by negative 7 we would just be left with x. And 21 divided by negative 7 would be negative 3 equals 0. So both brackets have the same thing. So we write x take 3 in the first bracket and x take 7 in the second bracket equal to 0. So we can separate them now. X take 3 is equal to 0 and x take 7 is equal to 0, and we solve for x. So x is equal to negative 3. When we transpose it, we have x is equal to 0 plus 3. Therefore, x is equal to 3. And in this case, when we carry across the negative 7, x is equal to 0 plus 7 because it becomes the opposite of what it is. So x is equal to 0 plus 7 is 7. So when we solve this quadratic equation, x squared minus 10x plus 21 equals 0, we found that x is equal to 3 and x is equal to 7. For our final example, we're going to solve x squared plus 6x plus 9 equal 0. AC is equal to 9, and we're going to use 3 times 3 because when we multiply 3 times 3 we get back 9, and when we add it we get 6. So we could use these two factors. So x squared plus 3x plus 3x plus 9 equals 0. First pair, second pair. So what is common between x squared and 3x? That's x, open bracket. X into x squared is x plus x into 3x, 3. Next bracket, what is common between 3x and 9? We have 3, so we put it outside. 3 into 3x gives us x, and 3 into 9, 3. All of this is still equal to 0. So we have x plus 3 in the first bracket, and then we have x plus 3 again in the second bracket equal to 0. Now recall I did mention in the previous lesson that as long as we get to this stage and both brackets have the same thing, then we consider it to be a perfect square. So we could just rewrite it as x plus 3 all square is equal to 0. Right? So we're going to solve them. X plus 3 equals to 0. And we know that x plus 3 equal to 0. We don't necessarily have to work both of them out, because we know that when we work x plus 3 is equal to 0, it's going to give us the same answer because we have the same equation to solve. So x plus 3 equals 0. When we transpose the positive 3, it becomes negative. So we have x is equal to 0 subtract 3. X is equal to negative 3. Same thing over here. X is equal to 0. Take 3. So x is equal to negative 3. So when we solve this quadratic equation, x squared plus 6x plus 9 equals 0, we found that x is equal to negative 3. So for your homework, you're going to solve the following. The first, y squared plus 6y plus 5 equals 0. Number 2, 2x squared plus 3x subtract 2 equals 0. Number 3, x squared subtract 6x subtract 16 equals 0. And the final one, 8x squared minus 10x minus 3 equals 0. So, to summarize today's lesson, to solve a quadratic equation, we 1. Factorize using the AC method. 2. Set each factor equal to 0. 3. Solve each of these equations. And 4. Check by inserting your answer in the original equation. This has brought us to the end of this grade 9 mathematics lesson, where we explored solving quadratic equations. My name is Miss Donnell Phillips. See you next time.